All right, so you have a linear equation with fractions in it. So what's the idea? You want to get rid of the fractions, you want to clear the fractions. Okay, so you're going to do that by doing what? Finding the LCD and then doing what with that? Multiplying both sides by the LCD. Okay, so what's the LCD here? 15. So the smallest number that 5, 3, 3, and 5 go into, all these denominators, the smallest number that those go into is 15. Could someone have used 30? Yes, that's not the least, but it is a common denominator. Could someone have used 45? Yes. Any multiple of 15 would work. But then you making it a little bit more complicated by not using the least. So the least is 15. Now, we did a couple of things at that point. Remember, we then did it a couple of ways. One way was where I enclosed both sides in parentheses because there are two fractions here, which I did this. 15, oops, let me just do this. 3x divided by 5 minus x plus 7 divided by 3 equal, and then enclose that in parentheses. All right, now remember, we did that because there are how many fractions that you see on this side? 2. How many on this side? 2. Both sides have to be multiplied by what? The LCD, which is 15. So then you would say 15 times this, and then 15 times this. But we noticed that we could have skipped that step and just go from here to what I'm about to write. Because at this point, if you had written this step, you would notice that all of these fractions have to multiply by what number? 15. So 15 times this, 15 times this, 15 times this, and 15 times this, right? So you'd say 15 times 3x divided by 5 minus 15 times x plus 7 divided by 3 equal 15 times 1/3, and then plus 15 times 2x minus 1 divided by 5. Yeah.
So it wouldn't be understood that 15 is divided on 15 would be 3, so you multiply it 3 times with 3x, so that would be understood.
Say it again.
Okay, so you know how you say you have to multiply the
Everything by 15?
yes,
Yeah.
So wouldn't it be understood as just multiply the 3 times the 3x to get rid of the denominator or no?
Okay, say your question again. Wouldn't be, say it again?
Well, it's fine. Okay, so 15 times the 3x over 5, right?
Yes.
Since you already know that 5 times 3 equals the 15, would you just multiply 3 times the 3x on top and it cancels the denominator or no?
Basically what we're doing is, at this point, we're going to say 5 and a 5 is 1, 5 and a 15 is
Yes,
3.
that's what I'm saying. Like,
Yeah.
it would be understood as 3 automatic.
And he just breaks out every single step.
Okay, so you got to mathematically what you write has to be correct. So I don't know what you want to write. So why don't you write what you think is you're saying, and then I'll tell you if it's mathematically correct. Because you can't just say something without it being mathematically correct. Okay, so you got to be careful. Now, what some students do is they'll say 5 and a 5 is 1. They'll write that second step and they'll say 5 and a 5 is 1, 5 and a 15 is 3, and distribute the 3. You don't distribute the 3, you distribute the what? 15. Okay? All right. Okay, over here, you're going to say 3 to 3 is 1, 3 to 15 is 5. And then over here, you're going to say 3 to 3 is 1, 3 to 15 is 5. And over here, you're going to say 5 and a 5 is 1, 5 and 15 is 3. So the whole point of writing that step is for you to understand that the purpose of multiplying by the LCD is to get what numbers in that denominator? Ones. Now, the next step. What is 3 times 3x? 9x. All right, now be careful with this one. Last time, what else did we do with what I'm circling right here? We put parentheses there because some of you are going to say 5, this is 5x plus 7, and it's not 5x plus 7. Because not only is this x being multiplied by 5, but what else is being multiplied by 5? The 7. So since this has more than one term in the numerator, put that in parentheses. I didn't need to put parentheses here because it's just one term, 3x. Here that's x plus 7, two things. Do I need one here? Parentheses? Yes. All right, then we distribute the 5. What do I get here? Remember, I'm distributing in negative 5 though, right? Negative 5x minus 35 equal, what's this? 5, good. I'm going to distribute a positive 3, correct? So what do I get? Positive 6x minus 3? All right, so that's where I'm at. Combine like terms next, good. So when I combine like terms, on the left side, what do I end up with? 4x minus 35? Wait, plus 35? Did I do something wrong? Minus, right? Okay, minus 35. Equal? What do I get here? Let's put the x first. 6x plus 2. All right, so that's where I'm at. Now remember we said, and on My Math Lab, they're going to talk about the word equivalent equations. Are all of these equations I've written equivalent, called equivalent equations? Yeah, they're all equivalent equations because all these equations have the same solution. So equivalent equations are equations with the same solution. There's no way you could have looked at that equation right here and indicated what the solution is. So what you're doing is writing equivalent equations to get to the point where you can determine what the solution is. So again, you can't look at this right here and tell me what the solution is. So let's write an equivalent equation. So what's the next step? Variables one side, constants the other. So what do you want to do first? Okay, so you're going to subtract 6x? Subtract 6x, right? Not add. Adding 6x, mathematically adding 6x is correct. What you do one side, you do the other, but it doesn't help you. 6x plus 6x is 12x. That doesn't help. So you're going to subtract. Because when I combine these terms, this is 0, right? And what's 4x minus 6x? Minus 35 equal, and what's left? 2. What's the next step? Add 35 to both sides. Combine like terms. What's left over here? What do I get over here? One more step and you're done. What's the next step? Divide by negative 2. Now negative 2x, but what? Some of you are going to put negative 2x and you're going to be upset. You only divide by the coefficient. You want to get x by itself. So what's negative 2 divided by negative 2? 1 times x is x. So you got x by itself. So what's your answer? 37/2. So that's your answer. Leave as a fraction. All right, so we talked about something like that last class period. Now, we were about to, after break last class period, I had written out, I think I had written out this one. I'm not sure, but if it's not, it's similar to it. Negative 6 divided by 7x plus 2/3 equals 1/3 minus 1 over x. I don't think we did that one, did we? In the notes? Those of you that picked up the notes? I don't think we did. I don't think we did any with variables in the denominator. Okay. All right. Now, this is not a linear equation. This is not linear. All the equations we did last class period and the one just now are linear. Why is this not linear? Although you say, well, x is being raised to the first power. Yes, I agree. X to the first, x to the first. But your variables cannot be located where? In the denominator. So if you do have variables in the denominator, it's not called a linear equation, it's just called a rational equation. So a rational equation. So this is a rational equation. So a rational equation is the equation that contains rational expressions. So for us right now, just think about rational expressions where you have something that looks like a fraction. You have a numerator and the denominator. All right, now, I'm going to go back. I'm going to show you this right here. The one we just did. This is a linear equation, right? Okay. It is also a rational equation. It's a rational equation because 3x over 5 is a rational expression. X plus 7 over 3 is a rational expression. All right, so this is still a rational equation, but it is also considered what kind of equation? Linear. This is a rational expression, but it is not linear. Okay. So for right now, you know this. All the equations we dealt with so far have been rational equations. For the most part, they were linear. Now we have one that's not linear. All right, now this one's easy enough to where if you look at all the denominators, those are all one terms, right? 7x, 3, and x. Remember, the whole idea is to multiply both sides by the LCD. Okay, let's think about this. Don't make it difficult. Think about it. Look at the coefficients first. 7 and then the constant. 7, 3, and what's this coefficient right here? 1. What's the smallest number that 7, 3, and 1 go into? 21. So I know so far my LCD is going to contain 21. Now remember, when we multiplied 3x divided by 5 by 15, the whole purpose was to get rid of that denominator, make that denominator what? 1. What else do you see in this denominator? An x. So if I want to get rid of that 7x, then my LCD has to contain a x. And if I want to get rid of this x, then my LCD has to contain an x, and it does. So what's my LCD? 21x. The LCD is 21x. Okay? That's your LCD. So it's very easy to rationalize what it was. Because everything in the denominator, you want it to go into the LCD. So if you see an x, you better have an x in the LCD. Does 7 go into LCD? Yes, because 7 goes into 21. Does 3 go into LCD? Yes, because 3 goes into 21 evenly. And then all these fractions have to be multiplied by what? 21x. So I'm kind of skipping this second part right here. I'm going from the original problem to this step now. So I'm going to actually write out, I'm going to say 21x times the first fraction plus 21x times what? 2/3 equals 21x times what? 1/3 minus 21x times what? Well, I already put the minus up. This right here? Okay. All right, so that's what you do. All right, now at this point, once I multiplied every fraction by 15, what else did I do? I reduced, simplified, right? Okay. So remember, the whole point of multiplying the LCD is to get what number down here? 1. 7 into 21 is 3. X into x is 1. X into x is 1. You got 1, right? So 7x goes into 21x how many times? 3. And what's 3 times a negative 6? Negative 18. So that's what that becomes. Let's reduce this. The whole purpose of multiplying by the LCD is to get rid of this 3 to make it a 1. 3 and 3 is 1. 3 and 27 is? 3 and 21 is 7. So what is, look what I'm doing, 7 times x times 2? 14x. Make sure you saw how I got that. 7 times x times 2 is 14x. Equal. Can I simplify this term right here?
Yes.
Yes. That's what you want to do. You want to get rid of the denominator, so you better have multiplied it by the LCD. 3 into 3 is 1. 3 into 27, I keep saying 27. 3 into 21 is 7. So what's 7 times x times 1? 7x. Minus. Can I reduce this? Yeah, the x divide out, right? X and x is 1, x and x is 1. So I get minus what? 21. Very good. All right, so that's where I'm at. Yeah, now at this point, remember when I did this one? Now I'm at this point. When I did this one, the next step was to combine like terms. Can I do that here? No, they're not like, though on both sides there are no like terms. So then I go to the next step. What's the next step? All right, so let's do the variables first. What do you want to do? Subtract 7x. So I get negative 18 plus 7x good equal, these cancel out, and what are you left with? All right, a couple more steps and you're done. What's the next step? Combine like terms. I get 7x equal negative 3. And then what's the next step? So what's x equal to? 3/7. And there's your answer. That's all you do. Okay. All right, let's look at this one. Okay, this is number 3. All right, you have 2a divided by a plus 2 minus 5 equal 7a divided by a plus 2. Okay, write this down. Yeah. Okay, now before I go on, remember these are rational equations, right? Okay, so whenever you deal with rational equations, you want to restrict. You have to think of restrictions. You have to restrict any number that makes the denominator 0. Okay, so we'll write this down. For rational equations, you need to find your restrictions. Find the restrictions, and basically the restriction is this. Any number that makes the denominator 0, just the denominator. Any number that makes the denominator 0, and it makes sense because you cannot divide by what? 0. Put that in your calculator. Put 8 divided by 0 in your calculator. You're going to get an error. You cannot divide by 0. So when I go back to number 2, did I see a variable in my denominator? In number 2?
No.
Yes, I did. There's a variable. You see a variable, right? Okay, so I have to find the restriction. And so I need to talk about restriction. This is 7x, right? What makes the denominator 0 when x is what? 0, because 7 times 0 is what? 0. That's how you think about it. What makes this denominator 0? Well, this denominator 0 when x is what? 0, because 7 times 0 is 0. Is this denominator ever going to be 0? No. It's always what? 3. There's no variable. Is this denominator ever going to be 0? Nope. It's always 3 because there's no variable. What makes this 0? 0. So I found my restrictions. X is 0. None, none, x is 0. So what's my restriction? All right. So at the beginning, when we do number 3, we have to list the restrictions. The restriction will be that x cannot equal 0. Okay? Now, some students in college algebra, when they write the restriction, they always write x cannot equal 0. That's not true. Your denominator can be what? 0. That's what I'm saying. The denominator can be 0. So when I look at number 3, so number 3 is easy enough to look at it and determine what it is. My denominator is a plus 2, right? What number for a will make this denominator 0? Negative 2. Very good. Because what's negative 2 plus 2? 0. What's this denominator right here? 1. Never 0. When will this be 0? When a is what? Negative 2. Basically, all you do, if you don't want to guess like we just did, is just take the denominator and set it equal to 0 and solve for the letter. So how to get a by itself? Subtract 2. And so what's a? Negative 2. So you found your restriction. My restriction is that a cannot equal what? Negative 2. Now that's going to be important when we get to one that involves something that doesn't work. All right, so you have to find your restrictions when you have a rational equation. So let's go back to number 1. Did I have to worry about that here in number 1? No, because there were no variables located where? In the denominator. So I didn't have to worry about restrictions. You only have to worry about restrictions when your rational equations have in their denominator a variable. Okay? All right. Now, this one's easy enough, just like we did number 2, where you can guess as to what the LCD is. So remember number 2, we said that we looked at the coefficients first. We found 21, and then we looked at the variable x. So if I want to get rid of this x in the denominator, I have to have multiplied by x. The problem here is that this is a binomial. So it's not 2a, it's what? A plus 2. Okay, so that's different. 2a is different from a plus 2. 2a is multiplication, a plus 2 is addition. So if I want to get rid of a plus 2, what do I need to multiply this fraction by? A plus 2. If I want to get rid of this a plus 2 here, what do I need to multiply it by? A plus 2. So what's your LCD? A plus 2. That's your LCD, a plus 2. Now, how many fractions do you see altogether? How many on this side? How many things do you? How many terms do you see? 2. How many do you see here? All right. So I multiply these three things by the LCD. So here's how you're going to write it. You're going to say 2a divided by a plus 2 times what? A plus 2. Minus 5 times what? A plus 2. But look, this is not a good way to write this, because some of you are going to say that's going to be minus 5a plus 2, and it's not. I need to put this a plus 2 in parentheses. Okay. Minus, and then 7, I'm sorry, equal. And then 7a divided by a plus 2 times what? A plus 2. Okay, so I multiplied all 3 fractions by the LCD. And now we reduce. The whole point is to get what down here? 1. A plus 2 into a plus 2 is 1. A plus 2 and a plus 2 is 1. So what does this become? 2a. Okay, over here I've got to do what though? Distribute. So that's why you need parentheses. So it's very easy to have missed this part. Now you would have gotten, if you had just not forgot to put parentheses and did everything else correct, you would have gotten most of your points, but you wouldn't have got all of it. What does this become? Minus 10. Good. Minus 5a minus 10. and equal. What happens here? Those divide out. What are you left with? 7a.
And you combine your like terms.
Combine like terms. So what does this become? Negative 3a minus 10 equal 7a. What's the next step? I would add 3a to both sides. Combine like terms. This is 0 right here. So what's left? Negative 10 equal 10a. One more step and you're done. Divide by what? 10. So therefore, what is a? Negative 1. Okay, now listen. Once you remember this was a rational equation that had a variable in the denominator, right? And it had a restriction. I said that a could not equal what? Negative 2. Is my proposed solution this restriction?
No.
No, so we're good. So that's your solution. In a little while, we're going to do one where this number is actually this, and we're going to talk about what that means. All right, so for right now, you just check and see, is this? You're good if it's not. So that's your solution. A is negative 1. Now let's just check this. Let's check it. Let's go ahead and check this. So where you go back to the original equation, and wherever you see the letter A, what do you plug in? Negative 1. All right, so look, I get 2 times negative 1 divided by negative 1 plus 2. Is that correct? All right. Minus what? 5. And I want to see if that's going to equal, notice a question mark. I want to see if that's going to equal 7 times what? Negative 1 divided by negative 1 plus 2. What's this numerator?
Negative 2.
What's this denominator?
1.
1. So that's negative 2 over 1, right? Minus 5. Check and see if that's equal to. What's this numerator?
Negative 7.
Over what?
1.
1. So what's negative 2 and a negative 5?
Negative 7.
And is a negative 7 equal to negative 7?
Yeah.
Yeah. So negative 1 is a solution. Okay? All right, so that's number 3. Let's look at number 4. Number 4. All right, now listen carefully to this. Okay, here's what number 4 looks like. Now we're getting to the point, remember last semester you did a bunch of factoring? There's a whole chapter on factoring. All right, we're getting to the point where you're going to need it. Not with this one, you don't need it with this one, but we're getting to that point. Okay. All right. So you have this rational equation, right? And you have variables in the denominator. So one of the things you got to remember, one of the things you have to remember is that when you have a rational equation, there are variables in the denominator. You have to list your restrictions. You have to list your restrictions. So t cannot equal, that's what you got to find. All right, so look at the first denominator. So all you got to do, look at the denominators. Those are easy enough to where you can tell me what the restriction is. T cannot equal what number here? Negative 3, because negative 3 plus 3 is 0. Remember, your denominator can be 0. So what makes this denominator 0? When t is negative 3. So that one's negative 3. Look at the next one. What makes this denominator 0? When t is what? 0. Very good. What makes this denominator 0? Negative what? 3. We already have it. So how many restrictions are there this time? 2. What are they? Negative 3 and 0. All right. Now, right now you don't know, well, why are we finding the restrictions? You're about to find out. I think it's with this one. Okay, now let's find the LCD. So you found your restrictions, then you find your LCD. Remember, the whole purpose of multiplying by the LCD is to make this denominator what number? 1. So if this is a t plus 3, then my LCD has to contain a what? T plus 3. If I want to get rid of this t, then I've got to also have a factor of what? T. So I got to multiply that by t. If I want to get rid of this denominator, then I've got to multiply by t plus 3. Do I have a t plus 3 already listed in my LCD? Yes. So what's your LCD? T times t plus 3. That's your LCD. T times t plus 3. So all of those three fractions have to be multiplied by the LCD. So you're going to say 1 divided by t plus 3 times the LCD, just like this, just like that, plus 2 divided by t times the LCD, just like this, equal 9 divided by t plus 3 times the LCD, just like this. After a few more, finding the LCD is going to be very easy, because for us, it's not the complicated kinds. It's the simpler kinds with this chapter. All right, so the LCD, you have to find the LCD first before you multiply by the LCD. Now the whole purpose of multiplying by the LCD is to get this to be a what down here? A 1, so that's where we reduce. T plus 3 into itself is 1. So all you have left over here is t times what? 1 times what? 1. So what's t times 1 times 1? T. Okay, that's just t. Plus, okay, let's talk about this one. I want a 1 down here, right? So t into t is 1. T into this factor t is 1. So you got to be careful now. I have 1 times t plus 3 times what? 2. So here's where I'm going to write it out. I have this then. I have 2 times t plus 3 in parentheses, right? 2t plus 6. Very good. So this right here becomes t plus 2t plus 6. You have to distribute. What happens over here? T plus 3 is divide out, and you're left with t times 1 times 9, which is 9t. All right, so here's my equation now. Okay. Combine like terms. What's t plus 2t? Plus 6 equal 9t. Subtract 3t from both sides. I get 6 equal 6t. And then divide both sides by 6. I get t to be what? Is that one of your restrictions? No. So that's a solution. That should work. That's your solution. So we haven't gotten to the point where our proposed solution is one of the restrictions. Hopefully we'll get to that point today. All right, now let's check it. Let's go ahead and check this. Let's check it. Wherever I see a t, what do you plug in? 1. All right, so I get 1 divided by 1 plus 3, right? Which is really 1 divided by what? 4. Plus 2 divided by what? 1. Equal 9 divided by, remember t is 1, 4. Do y'all remember that the LCD here is 4, right? So 1/4, and do y'all agree that 2 is the same thing as 8 over 4? Yes or no? Okay. 8 over 4 is 2. So what's 1/4 plus 8/4? 9/4. So 1 works. 1 is the solution. All right. Now,